Nistin sir, are you there in the meeting?
Yeah, I'm.
Okay, Nistin sir, you can take the session. Thank you.
Thank you, Mr. Dev. So, let me share my screen. I hope my screen is visible.
Yes, sir.
Yes, sir. Yes. Welcoming you all for the second webinar session on PCB printed circuit board. This is the basic way, and we are discussing on the basic that is from scratch on this session. How to design a circuit, how to convert the circuit into a PCB. Let us go with the flow like a step by step, so that we can understand what is PCB, how to design a circuit, then how to convert a circuit into a PCB. So here your session begins. So we'll go with the step by step. Initially, what are PCBs? So we all know that PCBs are the backbone for the electrical devices. Like it will stand like a pillar for the electric component. So without the PCBs we cannot connect any component, or we cannot build any circuit. So it acts as a backbone for the electrical devices. So basically it is a non-conductive board, so that it holds all the electric components through a circuit, which is then molded over it. The electric components are molded over it. PCBs are built to last for a wide range of industrial, commercial as well as the domestical applications. You can see PCBs in everywhere. So they can be customized to any specifications as you desire, as you prefer. That's all. What is the definition and what is the PCB? So when it comes to history of the PCBs, let me tell you that these PCBs were initially developed during the Second World War. This was invented by an Australian engineer called Paul Eisler, and in the year 1929, PCBs have made a mass produced for commercial applications. As you all know, the first use of PCBs is in the transformers and capacitors. So moving further, what are the PCB types? When we are discussing about the PCB types, we will classify into three types: single-sided, double-sided and multi-layered. You can see in the pictures, the first picture says a single-sided. How can you differ a single-sided and a double-sided? That shows in a second picture. The single-sided PCB type, it has only one copper layer. That means the base material which is molded with the copper only at one side. But when it comes to double layer PCB, there are base material with copper in both the sides, that is top layer and bottom layer. That's how we differ the single layer and double layer. When it comes to multi-layered PCB, it is encompasses with several layers of substrate. That's how the single-sided, double-sided and multi-layered PCBs are different. So I added this picture. It will tell you in the next slide. This is the flexible PCB. I will brief you about flexible PCBs. I hope you clear the PCB type: single-sided, double-sided and multi-layer. The main difference is multi-layer, it contains several substrates. That's all. So here comes the board types or board types. The most common board types are rigid, flex and rigid flex, and at the last hybrid. What is rigid? What is flex? what is rigid flex, what is hybrid. I'll show you the picture so you can differentiate what is rigid, flexible and rigid flex. Just go through the picture. Alright. So as I explained in the previous slide, single-sided, double-sided, multi-layer. You can differentiate single-sided and double-sided as in the picture, and multi-layer which contains several substrates. When it comes to rigid, flexible and rigid, flexible, you can see that the rigid PCBs or the solid construction, which can be called as hard boards. When it comes to flexible PCBs, it will be like we can move the board as we can, like it will be flexible as flexible. So rigid, flexible in the sense multi-circuit board. So you can link the one circuit board to the another circuit board. So at last, hybrid or high frequency. These are the like very small circuit boards that can be integrated as a part of large circuit. We can integrate a small circuit in a big circuit. That's how the hybrid or high frequency circuit board is. So when we move further, there is parts of a PCB. Parts of a PCB. Like these are the very important thing which is required to build a PCB or to build a circuit board. As you all know how these components are required for the PCB. So the components you can say these are capacitance, resistor, LEDs, but we have to differ what are the capacitor or resistor belongs to and LEDs belongs to. So we differ into two categories, that is active and passive components. What are active components? Active components are diode, transistor, ICs in the sense integrated chip. Then that's all for the active components. So what are diodes? You all know these are the basics. Diodes are the things that allows current to flow in only one direction. What is transistor? Transistor amplifies and switches electrical power and electronic things. IC, which are responsible for the several signal processing process. That's all for the active components. When it comes to passive components, it includes capacitors, resistors and inductors. What are capacitors? Capacitors are the components which stores and discharge electricity. So when it comes to resistor, it limits the power of electrical current. And at last, the inductor, which is responsible for creating magnetism. So these are the parts of a PCB which are very important to design a PCB. So these are some other parts of a PCBs, like we can say pads, tracers, wires, top metal layer, bottom metal layer. These are also very important with the others. So pads are the location where we connect the component or we solder them. Pads. I think I had some pictures. Not there. Tracers which connect pad together. We can say that the two or more pads connecting is known as tracers. When it comes to wires, it is responsible for making electrical connections between the layer of the PCB. There will be 2 layers or 3 layers. We can connect the layers through wires. Then top metal layer and bottom metal layer. I can explain these 2 points in the software part. So you can see the 3D model over here. Top metal layer, bottom metal layer. Actually we have an option in software viewing the circuit as 2D and 3D. Oh, package types. What are package types? Can we design a circuit without package types? No, we can't. So package types are the components, like it can be mounted on a board in 2 ways. What are the 2 ways? surface mount and through hole. By seeing the pictures, you can only say how the surface mount defines and how the through hole defines. Surface mount. What is surface mount? PCB components are mounted directly into the hole. We can solder the component directly into the mount. So what is through hole? Through hole are the components which are inserted through a mounting hole. There is this, you can see in the board, there is this small mounting hole. We can insert the component directly to the mounting hole. Those are defined by through hole. So these are the manufacturing or assembly steps. Like we have a PCB design and we have to manufacture them. So we go through these from 11 to 12 industrial steps. Let me explain one by one so that you can get an idea how the PCB manufacture or how it goes to manufacture step by step. Basically, it goes first with the base material preparation, which cleans up the laminate containing the copper foil. In the second step, it will cut the base material, which post the cleaning process cut the laminate to required specifications. Then it will apply adhesive on the laminate. We choose between XOP or acrylic adhesive to get the job done. We have to finish that by applying these things. In the next step, there is step 4, generating circuit pattern. So we will be having a desired circuit pattern that can be generated by screen printing or photo image. In the step 5, etching the screen pattern, that is etching the copper laminate containing the circuit pattern. So we'll move on to the fixed point. Fixed point is which goes with the drilling. The drilling the holes pads by using high-speed drilling. I already explained about pads and wires. I think you got a point. So with 7th step, through hole plating, deposit the holes with copper and must be chemically plated. In the 8th step, we'll apply a cover layer so that it will protect the top and bottom side of the board by applying suitable cover layer. Then cutting the flex. In the 10th, the cleaning process will take care. Then in 11th step, testing, that includes automated optical inspection, flying probe test, functional test and Berlin test. In the 12th step, we'll rework done on the PCB in case of component missing. So in the 13th step 13, in case we have to replace any component, we'll do in a step 13. So step 14, trace or pad repair. In the 15th step, cut and jump. We'll figure it out and we'll send it to the cut and jump. Plus the PCB material option. As I said that every step is very important to design a PCB. So when it comes to material options, manufacturing PCBs, there are several material options are available. Substrate material, conductor material, adhesive and protective coating. What are the material comes under substrate material? Epoxy imprinted finger glass, polyester, polyamide. In conductor material, electro-deposited copper foil, rolled copper foil. In adhesive, polyamide, adhesive, polyester, acrylic, epoxy. In the protective coating, the things comes under protective coating, polyamide, coverless, cover coating. What is cover coating? It's a thin coating of liquid acrylated epoxy, which like acrylated polyethylene or several materials or options are available over here. So we learned the basic thing, what is PCB, what are the types, what are the basic boards. So now the thing is how to design a circuit, how to design a PCB. Is it easy to design a PCB? Not a bit. So there are some software to design a PCB. These are the top PCB software which are used nowadays. I didn't mention the Eagle. Okay, Eagle is here in the option 3. Autodesk Eagle. It is one of the main PCB software which is used by nowadays. But as of now, I'll show you the easiest and a simple way software which is called Easy ED. Basically, it is a simple and a acoustic small online tool. It is very simple. We can learn and design a PCB in a short time. More than that, the spy simulation is also supported by ED. It's a good news, like it's a good part in the PDA tool. So we can simulate the spies also over there. And also the important thing is it is a web-based software. Without wasting further time, let's jump into the software part. I'll show you how to install and what are the things to be taken care in the software part. So yes, you will find Easy EDA in a Google Chrome. So this is the largest PCB library. As I said, Eagle is also one of the most used PCB software, but one second. So this is the, like, as simple as we can design in a short time a circuit. So this is more than 1 million free library. It consists more than 1 million free library, and we can easily design a PCB with a small circuit. So you have to download over here. So for Windows, for Linux and for Mac. And I haven't downloaded version, I'll show you. So here is, most of the engineers choose EDA software. So next time it's software thing. I hope my screen is visible. So see, this is the layout of the EDA software. Here you will be finding a file for creating a project, and these are the components list. Like inside you can find the components. Then just choose a file. Then you go to new, and you will get a project and create a project as new file. So in this we are creating a simple circuit regarding LED. So I am creating title as LED. If you want to add a description, just add the description so that it can be saved for the further use. Save. So we have a layout. So this is called canvas. Canvas for the PCB circuit. So this will be size around like width of 1169 and height of 826. This is A4 size. You can print it. You can also print and you can keep it with you. So These are the components list, components bar. I hope you can see all the components over here. I am going to explain a short circuit, like a simple circuit, so that you can understand how the software works. So, what are the things required for LED circuit? You all know, this is the basic thing. So we'll go with the circuit. So first one, we'll choose a resistor. Okay. Let me tell you how to choose a component. Just tap on the component, drag it on the canvas. No drag, just move the cursor to the canvas and right click. Then to leave the component, left click. That's all. How you works in the CAD? The same method you use in this thing also. So we added a resistor. Then we'll move to the LED thing. We need one LED. So LED. Yes, LED is done. Then after LED, what we need? Just a power supply, simple. So for power supply, to rotate or to change the direction of the component, just use the space bar. That's all. It's done. Resistor, LED, and then power supply. So what is the next step? We'll go through the wiring. Wiring, resistor to diode, resistor to power supply, diode to power supply. Done. Don't you think this thing is some? Okay, we'll move this component of this. One second. Okay, it's done. So what is the next step? VCC. Just add VCC. Then go with the ground. Done with your circuit. That's all. So in the sheet name as the lady Laikapace, I'll add Laikapace. So your sheet name as same. Then controller. Save your file so that you can go to the next step, that is for PCB. Controllers. Your project as saved. Then if you want, there are so many options. You can view the canvas in black and white, so it will be more clear. You can identify any mistakes in black and white sheet. So preview window, you will get the preview window also. So many options are there. So without wasting further time, we'll move to the PCB. So we are converting this schematic diagram, that is the circuit diagram, into a PCB. Taking process. So we'll place this PCB in a circular frame so that it will look what, in a nice and this is the circular frame which the PCB looks like. So select all these things and place it in a circular frame. One second. Select all the things. All the things came. So the thing is, place it's looking like a clumsy, right? So we'll make it clear and we'll make the component look nice. So nothing is needed, just we have to just the components or the PCB board should look nice, right? It should not be clumsy or some congested. So we'll place like so I think it's fine as of for now. Yeah. Okay. So we'll go with the wiring thing. This is the wiring component. Zoom for your comfort. So before wiring, go with the width. We'll keep the width as 0.58, so it will be perfect. Place the wiring, then go with the second wiring. It's done. Then third one. Yes, it's done. I think yeah, everything is fine. Escape to close the component or to close the what you took. So we'll place everything in a center. It's in center. Yeah, fine. Our component is ready and it's ready to print. The PCB is ready. You can ask like, what is this? Is it looking like this? So after printing, it comes in a PCB way. So to check that, we can view it in a 2D way. So this is the PCB. So it's not looking like a PCB, right? So yes, we'll see in a 3D way so that you can get an idea. Yes. This is our PCB for this session. The LED simple circuit. You all know why we are using resistor to control the light emitting light, to control that light, because it should not burst in a one-set power supply, right? So this is the power supply will give. So you can see over here the plus or minus power supply in the 3D view. Yeah, this is the power supply and LED and resistor. So our PCB is ready and we are ready to print the PCB. I think we have still more time. Do you have any doubt with the software thing, guys? So one second, let me show you some other circuits which we done in our organization. My screen is visible, right? This is the battery management which we done for our organization. Let me show you the flight simulator. Yeah. This is the flight simulator. This is the front end set and this is the main part. Let me put it in 3D way so that you can get a more idea. Yeah. This is the flight simulator which is used for company. So if you want to view in 2D way, this is how it looks. So this is 3D. So this is the final output and we are going to print this PCB. And so basically why we use this PCB? If we get a project to do in college, we'll show in a breadboard or some box and all. So instead of that, showing that project in a PCB, it will be more efficient and more good thing for the faculty also. So PCB is better than a breadboard or something, and PCB is very simple to use or to design. Everything is just, as I said you, just a drag and drop thing. See, this is our canvas, right? Just take a component, drag it over here. Take a component, drop it. That's all. Then take a component, drop it over. That's all. That's all. See, just drag and drop. So we'll move to the presentation. We have still more minutes. Yes. So as I said, application. What are the applications of PCBs? So PCBs are used in many domestic and commercial commercial ways. So first one, initially it is used in medical, military, aerospace, telecom. Medical, they are used in image equipment, drug delivery systems, wireless controllers. So in case of military, weapon guidance systems, communication system, GPS, aircraft, missile launch detector. So in the aerospace, radar equipment, GPS, radio, communication system, control tower system, and even in the sensor side. So when it comes to telecommunication, base stations, handheld units, communication satellite, wireless communication system, signal processing system. So, and also these are also used in automotive, manufacturing, consumer appliance. Everywhere the PCB is over there. So, yes, and we compare it with the applications. So yeah, we are at the end of the session. If you have any questions, please shoot or please ping us. Just drop your questions in chat box. We'll get back to you. So please go through the questions. We can have a good interactive session. Yes, do you have any doubt? Please ping me. Don't hesitate to ask a question. We'll figure it out. If you have any small doubt, just clarify. Any questions or any queries regarding the presentation or regarding the session, or if you have any queries regarding the company, Laikapace Pvt Ltd, just ping us. You can see all the details over here.
Yes, I also like to add some points. Like we are providing internship for 1 month for the next month. If you guys are interested, then you can visit our website and you can join that. Also, on 3rd and 4th of April, we are going to take session on basics of CAD. So basically, in that we will be discussing about the designing and plotting of lines, planes, solids. Okay, so if you guys are interested, you can join that also. Details are there on the website, so please check the website. Thank you.
Can you share the recording of the session?
Yes, it will be uploaded in the YouTube channel of Laikapace Pvt Ltd. Please subscribe the channel.
Okay, sure. You'll get all the information in the website. Please go to the website.
Okay, thank you, Mr. Nishin, for this. Yeah, sir, please continue.
No, I hope no questions from the students or from the registered people. So, if you have any queries, please ping or please ping to the company or DM to the company. We'll figure it out. We'll get back to you. So, thank you, Mr. Dev.
Thank you, Nischint sir, for the wonderful session. That was actually wonderful. Like even I was also listening properly. Like so many things I learned today about designing of a circuit. Thank you so much for that. And also, students, if you're having any doubt, you can directly contact us. Even you can join the internship and also the upcoming webinar. So that's all for today. You guys can leave. Thank you.